This is part 3 of the series where we're refactoring this original tutorial by Kids Can Code. We're now on part 3 with collisions and bullets, and this is the section also using Pygame but with some major changes. The code for it is in my GitHub repository here under episode 3 bullets and collisions. I'll leave this in the link in the description, and obviously you'll need the Pygame files for that. So let's just bring the code in. So I'll just show you what this one is doing. If we start it up, that's the wrong version. That's a bit later on. So this is number 3. There we go, and we'll get that playing. So all we've got here is a green rectangle as before. It's moving as before. It's got these mobs dropping as before. But now we've added the bullets by pressing the spacebar. So if you hold the spacebar down, you get a pretty continuous stream, or you can just get one at a time. As you can see, the collision is now working in that if I hit a red rectangle, I am getting rid of them. This is in very much slow motion because we're in debug mode. Okay, let's quit that and we'll get on to how it's all working. So the first thing we need, of course, is a bullet class. Again, this is a proper class in a file called bullet with a lowercase b and with a class called bullet with an uppercase B. So again, when we are ready to create bullets, we have to remember that bullet.bullet syntax. The class itself takes the x, y, width and height and a color as parameters, and then sets up a rectangle, Pygame rectangle, and it's been given a default speed of 1000. I've now got this if shared debug included in it, so that if we're running in debug mode, we halve this. Well, I've got it at 400, let's put it at 500, so it's half the speed. There we go. And then we have this self.active, which is a flag just which is set to true by default. We can return the rectangle if it's needed by any other parts of our program, and then the update and draw methods run 60 times a second because they're called from the update and draw functions in the main script here. The update, what that does is to move the rectangle's Y position in a negative direction determined by the speed and delta time, so it will move it up the screen so that you're shooting upwards. When it reaches the bottom of the rectangle is less than the screen height, then the active state will become false, so that you can then return that to the update function so it knows whether or not that bullet can be deleted. So that's the class itself, fairly simple. We'll just go back to the calling functions. Now main hasn't changed at all, that's exactly the same as it was. The load function, this part's all exactly the same as it was, except we've now got this shared.debug equals true, and that's what's allowing us to slow down some of the rectangles as they're going through. Let's minus that one. Then we've got the update function, and we've got some new code here, so that we don't have a continuous stream of bullets by just holding the spacebar down. We're introducing a delay so that you can only generate a new bullet after a certain period of time has occurred. So that's what this little section of code does. Now we could just use this kind of new bullet timer as the variable to hold that. But if it's declared up here, directly in this part of the script, because Python's stupid way of handling global variables, we can't update that value unless you put the word global and the variable name inside the function, which gets a little irritating. So what I've done instead is to create a very simple class called data. There's no constructor. All it contains is two variables. There's the new bullet timer and allow new bullet, a boolean value set to true. And the great thing about this is that we can call this data dot new bullet timer or allow new bullet from anywhere in the functions, and we can change the value without having to use the global keyword. Now, we didn't need to do it with new bullet interval because that's kind of like it's set at that amount. It doesn't change. It's more of a constant than a variable. And also lists and dictionaries declared here in the margin can be added to and deleted from without using the global keyword. So anything that doesn't need a global keyword is sitting here, and anything that does is going in here. So let's go back to the update function. So data.newBulletTimer is just the one that we created at the top in that class. We're adding delta time to it, and when that reaches the new bullet interval, which we set at 0.2 as our kind of default value, then allow the new bullet becomes true and new bullet timer is reset to 0. So as this runs 60 times a second, it means that every 0.2 seconds we'll be allowed to fire off a new bullet. Now, assuming that we're in game state play, if we press the space key down or hold it down, it will call the shoot function here. So let's go up to the shoot function. This is simple. It first of all checks, is our allow new bullet flag set true? If it is, we can create a new bullet. So we create one in this sort of temporary variable here. It's called by going bullet lowercase dot bullet uppercase because we're using the bullet class inside the bullet file, and then we're giving it the player's center rectangle in X and the player's top as the position which the bullet should be spawned, and then it's 10 wide. That's probably a bit deep, 40. Let's make it 30 in a yellow color, and then we're appending that bullet to our list. We can do that, although bullets has not got the word global up here, as I was saying, because it's a list declared here, we can add to it without any problem. And then we reset the bullet timer and reset the allow new bullet back to false, so that we're forcing this kind of 0.2 seconds delay. So that's how the shoot works. So if we go back down to our update function here, so once we've shot or not, depending on whether the spacebar is pressed, we then need to check whether the player is colliding with any of the mobs, or perhaps if I put it the other way around, if any of the mobs have come down and crashing on top of the player. So we'll have a quick look at that one here. So this is the check mob player collisions. So again, we're updating the position of the player, and then we're going through the list of mobs, updating each one's position, and now we're introducing the checking whether it's colliding with a player. So we're calling a new function called collides, and we're passing the rectangle from the mob and the rectangle from the player. So the collides one is up here. Okay, I didn't write this myself. I found it by searching the usual sources, and it's a relatively simple piece of code. all it does is to check whether the left side of one rectangle is beyond the right side of the second, or the left side of the second is beyond the right side of the first. In that case it will return false because they cannot be intersecting in that case, and it does similar thing for the tops and bottoms. So you either get a true or a false return from colliding with the two rectangles. The original tutorial from Kids Can Code was using group collides, which is part of the Pygame structure, but I wanted to kind of do it the hard way by creating our own collider, so you can see how it works. It's actually relatively simple, and also I needed to try and make it as compatible with the Love2D gaming engine, which doesn't have a collision event, and the Monogame, which does have an intersect there, but we're kind of keeping it as close as possible so that they all match. Okay, so let's go back to the update. So we first of all checked whether the any of the mobs has hit the player. The next thing is to do is to check the mob bullet collisions, which is another new function here. And what this one does is it has a nested loop. The first loop goes through the list of bullets, the second loop goes through the list of mobs, and then it checks to see, with the same collision detection, but this time passing the rectangle from the bullet with the rectangle from the mob, and if there is a collision, then it will remove that bullet from the list, and then it will reset the appropriate mob so that it goes back up to the top of the screen. And it does a final check so that if the number of bullets in the list is 0, it will then break the loop so that we don't get any errors. That's why this try except is in here. If you don't put that in, it sometimes errors with index errors, so I just put that in to stop it there. Now, once you've gone through to check whether any bullets are hitting any mobs, we then do a final update on all the bullets, so that any that are left because they haven't destroyed mobs, we're checking, can we update them here? If we can't update them, that means they've gone off the top of the screen, and again we'll remove them from the list, so the bullet is then destroyed. So that's how those work. Let's come back down to the updates here. Yep, that covers both the collisions with the bullet and the collisions with the mob. Just see if we changed anything else. I think the bullets we've already looked at. The mob, so a quick look at that one. No, I think that's pretty much the same as it was, and also, yeah, so that's the only changes that have been made, but it does now allow us to work on it. So if I just hit the, cancel that one, let's make sure we're on the right thing. If we hit the play button, and again you can see that spacebar held down, constant stream of bullets, and we're moving across here. Now if I reset and change the, from the load function here, change that shared debug to false, and then restart, I shall have to be a lot quicker, but you can see everything's working a lot. Oops, and I got caught, and so the game is finished. Okay, so that's the Python version, and we'll move on next time to introducing graphics.